Okay, guys, I said I was going to do this problem, which is number 3 on the motion review. I said I was going to do it in 2 parts originally. After having done the problem here on my notes, probably makes the most sense to probably split it up even further so you can pick out the parts that you specifically want. So this first video is simply just going to be setting up the problem. So it says a rocket sled accelerating off a 17-degree ramp. So I'm just going to go ahead and draw a triangle here and put an angle there, and we'll say that angle is 17 degrees. Okay, so we got some sort of rocket thing down here, some sort of, well, that's just a terrible picture. You get the idea though, right? This is a rocket thing with wheels on it. It's going to take off in this direction. Think of it as like a car that's going to get accelerated this way. It says that the ramp is 400 meters long. So that would be the distance it's going to travel there, 400 meters. It starts from rest, so we'll go ahead and say, I did this in a previous problem. Let's give positions here. Let's go ahead and call this position A, this position B, and then I'll probably use C a little bit later on, but for right now, we'll say that the velocity at A is 0. As I go through problems, this might change to the initial or final or something like that, but when we're dealing with multiple locations, it makes the most sense to say where it is 0. Then it says that there's a force applied on this of 20,000 newtons. I'm going to ignore that for a second because it probably makes sense for me to do a force diagram, and I'm just going to put that on the force diagram. It says that the mass is 2,100 kilograms, okay, and that the mu of this guy, so mu is equal to 0.4. I put it up here so I can just kind of point to where it's specifically at. If I had drawn this a little bit more clear, if I was using a pen and not this, I probably would have drawn it somewhere a little bit more clearly up here. It says the force applied leaves when it's going to turn off when they leave the ramp right here. And at its peak, so it's going to go through 2D motion, but at its peak, it's going to run into, it says, a giant bird dragon thing. So the reason for this particular part of the problem is that that's as good as I can draw a dragon, quite frankly. So bird dragon thing it is. So it's going to collide with that up there. That bird dragon thing is moving to the left, 8 meters per second, and it has a mass. We'll call it massive dragon. We'll come down here and say this is massive rocket. I believe that's 400 kilograms. All right. I believe that is everything so far, except, like I said, force diagram. Okay, so let's go ahead and do a force diagram. We're going to have force of gravity down. Okay, force normal is going to be perpendicular to the surface. If it makes more sense for you to draw it up here on the picture, that's fine by me. Force friction is going to be parallel to the surface but back. And the force applied is going to be right out the front right there. So that's force applied, and this is why I weighted. That's that 20,000 newtons right there. Okay, so now we're going to calculate the velocity 2.5 seconds after leaving the ramp, assuming it misses the bird dragon thing. Okay, so let's say A, and say we want the velocity, and that is velocity, not speed, let's go at 2.5 seconds after B. Okay, so after it leaves the ramp, right here, 2.5 seconds. We don't know if it's going up, coming back down, but we're going to have to do some stuff in order to figure that out. That should be, I think, everything to set up this problem. So there you go. I will do part A in the next video.